Let's continue our discussion on polynomial and synthetic division. To begin, we're going to begin looking at what degree of a polynomial. Now, most of us know what a polynomial is. It's something that might be in the form ax to the n plus bx to the n minus 1 plus c x to the n minus 2, and so on and so forth. The degree of a polynomial comes from its highest power, and that's what a degree is. It's the highest power. Now there's a couple of things that it tells us. One, it helps identify the type. Is it even? Is it odd? And two, it determines the number of factors and zeros that a polynomial can have. Now the third thing it tells us, it determines the maximum number of turning points that a function can have. And what I mean by a turning point is if I have like y equals x squared, it's a parabola. It has one turning point. A function like x cubed looks something maybe looks something like this. It will have a maximum of 2 turning points. So to get the maximum number of turning points, we take the degree minus 1. And that's how we determine turning points. Very simple to do. Alright, so for the following, what we're being asked to do for part 1 is this starting application is to write a complete factorization of a polynomial. Now when I write a complete factorization, that means we're going to factor. Now, so they give me this polynomial x cubed plus x squared minus 10x plus 8. Now we're told that x plus 2 and x plus 4 are factors. Now, remembering from yesterday, if it's a factor, the remainder must equal 0. So when I divide, I should get 0. So if I divide our polynomial by either one of these factors, we should get 0. So let's go ahead and do that. We're going to use synthetic division. This becomes 1, 1, negative 10, 8. Now I'm going to go ahead and do the first one, x minus 2. But remember, in polynomial, in synthetic division, we divide by the 0, the 2. Make your big number 4, 2. And bring down the 1. 2 times 1 is 2. 2 plus 1 is 3. Multiply, we get 6. Negative 4. Negative 8. We get 0. Yep, it's a factor. Now, right now my reduced polynomial is the following. X squared plus 3x minus 4. Now I know how to factor this by hand, and that's pretty easy to do, but they already give me one of the other factors, x plus 4. So I can also just divide this new one that we have by negative 4. So I might go ahead and do that. 1, 3, negative 4. Divide that by negative 4 here. Bring down the 1, negative 4, negative 1 gives me 4. I get 0. And there we have it. It is a factor. And my reduced polynomial is this, x minus 1. Now you may be asking, why didn't we put the negative 4 into the original one? You could have. It would have just given us another quadratic. And that's not really what I want. I want to make it easier, so I plug it into my reduced polynomial. It's kind of like saying this. If I take 18, 18 is divided by 6 and 3, right? If I take 18 and divide it by 6, I get 3, which is also divided by 3, divisible by 3. Even if I switch it around, 18 divided by 3, which is 6, that's divisible by 6. So it doesn't matter the order in which you divide. You can still just divide your dividend by the remaining factor. And that's what we did here. So our factorization, very easy. They gave us x minus 2, x plus 4, and we just found x minus 1. And that's the complete factorization. Now, what if we want to find the real solutions? We want to find the solutions. Well, to do that, to get the solutions, we take each factor, set it equal to 0. Whoops. So we get 2, negative 4, that's awful, negative 4, and 1. Factors, solutions. All right. you go ahead and let's try number 2 here. Now for number 2, this time they only gave us one factor. So I'm still going to divide it. 3, -4, -1, 2. And remember, we're going to divide it by the 0, which is a 1. Bring down the 3. Bring down the 3. We get 3, -1, -1, -2. -2, 0, and that's what I want. So that 0 tells me it's a factor, because that's our our factor theorem from yesterday, or our remainder theorem from yesterday. Now, since I don't have another factor that they gave me, I do have to write out my reduced polynomial. To get the other factors, that's what I'm going to do. Factor this, 1x, 3x. And let's see here, 1 and 2, I think that'll work. 1's negative, that's positive. 2 minus 3 is -1. Yep. So here are my factors, and I'm going to write them out. X minus 1, 3x plus 2, and the one that they gave me, don't forget that x minus 1. And what's really cool, we just factored this cubic graph. If we kind of like factoring from algebra 1, except for with 3 terms. Pretty cool, huh? Remember, I should expect to get 3 factors because that's my degree. It's 3. And then to get the zeros, set them each equal to 0. That gives me 1. -2/3, positive 1. And those are my zeros. And again, I should expect to get 3 answers because my degree is 3. All right. Try number 3. It's a little bit longer to do, but I am giving you 2 factors this time, okay? So we're going to try number 3, and then let's go and take a look at section 2. All right. Now, for section 2, it's a little bit tougher, more application type of problems, okay? For question number 4, it's asking us to find the value of k that makes the binomial a factor. So I ask myself, if it's a factor, what has to be true? The remainder must equal 0. That's the only thing true about a factor. The remainder has to be 0. So we're going to divide. I'm going to divide my polynomial. 1, -3, k, like what? -1, 15. I plug in my 3. Bring down the 1, we get 3, 0, 0, k. Cool. 3k, are you ready for fun? 3k minus 1. Because you got to add them together, be very careful with this one. Multiply by 3, 9k minus 3. Now, this is my remainder, okay? That's my remainder. And if I simplify this, we get 9k, be careful, 15 minus 3, plus 12. But remember, the remainder has to equal 0. So I take this 9k plus 12, set that equal to 0, and therefore k equals -12 over 9. So if you make this k a -12 over 9, x minus 3 then will be a factor. So let's go and try number 5. Pause this one if you need to. Try it again. And let's take a look at number 5. Same idea. I want 3x plus 2 to be a factor of this polynomial here. So I'm going to divide you. Okay. 15, 10, -6, k, 14. But what am I going to divide by this time? Ooh, that's -2/3. Ew. -2/3. Oh, luckily it'll work out. What's -2/3 times 15? Basically, take 15 divided by 3 is 5, times up by -2. -10. 0. That's easy. 0. -6. I like synthetic division. You can go fast with it. 2/3 of 6, you all should know that's 4. If not, do the math. Take 2/3 times 6. Cancel, cancel. 2 becomes 4. See? And it's negative because there was a negative there. Don't forget about that. Here we get k plus 4. And this is what I want. When I multiply, now be very careful, we get negative 2/3 k plus 4. Now watch what I'm going to do here. Don't be a hero. Don't be a hero and try to distribute, do something fancy. No, leave that as, I'm going to run out of room here unfortunately, negative 2/3 k plus 4 plus 14. That's my remainder. It's ugly, but that's my remainder. I set that equal to 0. And then we just solve it. Watch this. Add the 14, bring the 14 over. We get negative 2/3 k plus 4 equals negative 14. Divide by 2 is 7. Times 3 is 21. So we get k plus 4 equals positive 21. K is 17. You don't always have to simplify to solve it. You know how to solve an equation. Ugly sometimes gets it done. We like it. Definitely try number 5 again because of that fraction right there. All right, go on to section 2, and we're going to finish up with what we call the factor theorem. It's related to the remainder theorem, and it's very cool to work with. All right, and we will talk to you in a few minutes.